What is good, everybody? Welcome back to the channel. In today's video we are going to set up the command buffers. So in the previous video we took care of the graphics pipeline, so now we can finally focus on the command buffers. Now the command buffers is not really a lot of work to get set up, so I'm kind of contemplating whether I should actually infuse that with the vertex buffer creation video or not, but I guess I'll see as I go, as I'm recording this video, and see how long it actually takes us to create the command buffers. And if I feel like I can maybe get some groundwork started on the vertex buffers, maybe I might just add that in this video as well, but we'll see how it goes. Okay, so that's it. With all that said, let's get cracking. So hey, let's get our command buffer set up. All right, so back in our project now, let me just try and run this real quick, and just make sure that everything is working indeed, and yes it is. So in your renderer folder, right, in the renderer folder, in the Vulkan folder, we want to add 2 new files. So let's do Vulkan, and let's just name this one commands.h. okay, so that will be the Vulkan's command.h, and then just add the pragma ones here and then save that. And then we're going to add another file called commands.c, and then that one should basically include the commands.h file. So let's do that. So let's do Vulkan commands.h like that. All right, so let me just save that real quick, and then gonna come back into the Vulkan commands.h, and actually let's go to the Vulkan renderer.c, and let's actually include that file in here. So let's do include, oops, wow, can't type. So let's do Vulkan commands.h like this. Okay, and then once we have that, I think we're good. So I'm just gonna clear my consoles here, like this, and then just compile, and then clear this one on this end, yeah, and then hopefully that should work. So let me just close this files again, and then let me just show you guys something real quick here about command buffers. So this is the Vulkan documentation site, and it has some definitions and some explanations on how command buffers essentially work. So if you guys are interested, definitely give this page a read to essentially understand what command buffers are and what they are used for. Now I'm not necessarily going to go into too much details as to what they are and what they do, because the documentation explains that way better than I can. So I'll probably link this page in the comments, in the video descriptions below, so that you guys can just jump straight into it and then start reading about what command buffers do, right? And then you guys can just keep on reading and seeing what is this and what is that, and how you can actually create and use your very own command buffers. So with that said, let's get to it. So back into our code base, let's go to the Vulkan's commands.h. Actually no, before that let's go to our Vulkan defines.h, and in our Vulkan context, right below the pipeline here, we want to create 2 variables. All right, one is gonna hold our vk command pool, okay, and our command pool is essentially going to be the graphics command pool, okay, responsible for graphics. So I'm going to call this one graphics cmd pool. So the cmd is just a shorthand for command. You guys can spell it out if you want, but I'm gonna do it this way, okay. And then after we have that, we want to add in another variable here, and then this one will be the command buffer variable. So command buffer, but we want to hold more than one buffer, so we're going to create an array of buffers, okay, command buffers. So I'm going to name this command buffer cmd buffers, like so. And then this will be our array of buffers, and I guess I can indicate this like so. So array of command buffers for you guys, so that you guys don't get confused. All right, so by that pointer there, yeah, so now that we have these 2 variables here for the graphics, for the command pool, and for the command buffers, we can finally go ahead and implement our functions. So let's go down to the commands.h file, and then in here we want to define a couple of functions that will aid in the creation of our command buffer. So first and foremost, let's start off with the allocation for a command buffer. So if you look at the documentation here, somewhere down the line here, basically we allocate the command buffer and then we initialize it so that we can begin recording, and then basically we end the recording and then we can basically execute that command buffer, and then it can change into the pending state or the invalidated state, etc. So there's this whole life cycle of how a command buffer essentially works, and all the different states that it can be in. So we're going to start off with the allocation here. So we're going to do a function called Vulkan command buffer allocate, like this. And then what this is going to take in, well, let's just include our Vulkan defines.h header file here. So what this is going to take in essentially is going to be the vk device. So let's do vk device like this, and this will be a logical device. So logical device, and then we're gonna do a vk command pool. So let's do vk command pool, and then this one will be the command pool, and then we're also gonna need a boolean here. And if you look at the documentation, somewhere along the line here, it basically mentions primary and secondary buffers, right? So we're going to have primary buffers, and then we can also have secondary buffers, okay? So we can also indicate whether this buffer that we are allocating is a primary or not. So is primary is what this boolean means, is whether or not the buffer that we're creating is a primary buffer or not, okay? And then what we also want to add in here is a vk command buffer, and this one will be the out buffer that we create or allocate it using this function. So cmd buffer like this, okay? And that is our first function. Seems pretty long, isn't it? And then we're gonna have, since we're allocating, we need to be able to free that buffer. So let's just create another function called free. This one will also take in a logical device. It will also take in the command pool, and then I guess it will only take in the command buffer that we want to free. So that will still be a pointer, but then this variable is no longer needed, whether it's primary or not. Doesn't really matter, okay? At least in our context. So great. The next few functions that we need to do are going to be the Vulkan. Let's do Vulkan Vulkan command buffer begin like this, okay? Because if you look at this diagram, where is it? We have begin and we have end. So those are the two functions that we're going to add here. So for the begin function, we're going to take in a vk command buffer, right? So vk command buffer, and we're just going to take the pointer. So let's do command buffer. And then we also have the concept of single use, right? So if it's a one-time buffer, there's a concept of that. You guys can find it in here. So I'm gonna indicate that with a boolean here, is buffer a single use buffer. So single use, like so. And then we're also gonna have a function to end the command buffer, to end recording. So we have a begin recording and an end recording, and then we'll take in the command buffer, and we can just get rid of the boolean variable here, parameter. And then the other one that we want to do is reset. So we begin, end, and we also want to reset. So what we can do is just say void Vulkan command buffer dash reset. Okay, and then we can just say vk command buffer like this, command buffer, and then that should just take in the cmd buffer. So let's do buffer like so. All right, so now we have the begin, the end, and the reset. So the other additional functions that I'm going to add is that I mentioned that there's a concept of a single use buffer. So we want a function that will just create that buffer for us, right? So what I'm going to do is I'm going to say Vulkan command buffer allocate, okay, and begin single use. Okay, and this one will take a couple of parameters. Number one, it will take the vk device. So let's do vk device, and this is our logical device once again, and then it will also take in the command pool. So let's do vk command pool, and then this will just be the pool, and then it will also take in the vk command buffer. So vk command buffer, and then this one will be the out, so the buffer that we're creating, allocating, and using. So for single use, so it's just gonna be cmd buffer, okay, like that. Okay, so these are three variables that it takes in. So that is the helper function there for that. And then we're going to create another one to, this one is to begin, so we're going to need one to end. So we can just copy that, paste it in here, and then just rename begin to end single use. And then we should still take in the logical, and I just realized that I did not complete this. So logical device should still take in the logical device as well. Should also take in the pool, and then it should also take in the command buffer, and then I think it should also take in the queue. So let's do vk queue here, and then just gonna call this a queue. All right, and I misspelled it, so vk queue like so. All right, sweet. So these are the functions that we are going to make use of for our command buffer. So let's copy all of this and then go down to the implementation file and paste everything in here. So then we're just gonna open this up, right? Open everything up like this, and like this, and like this, and right down here, and over here as well. So now we can finally start populating these functions. Sure, let's see. So let's start off with the allocation. All right, so the allocation is pretty simple. I wonder if they actually show you how to allocate this in here. Struct command pool create. No, this one's for the pool creation. I don't know if they actually show you how to create them in here, but if not, it's fine because I do know how to create them. I just wanted to see if they show you. We have stuff to reset and all of that, so I guess you guys will just go through the documentation. I'm not gonna waste time there. So let's go ahead and create our command buffer, or allocate the command buffer. So let's do vk command buffer, and let's do the allocate info. Okay, and then call this alloc info, and this should be initialized to 0, and then from there we can just do alloc.info, set up the s type, and again the s type is just going to be the typical vk structure stuff. So vk structure, and then we're going to say structure type, and then it's going to be command buffer, allocate info, like this. Okay, and do keep in mind I hardly ever memorize the s types. They just given by the type of the struct here. If you just look closely, they always the same, right? So yeah, again, let's go ahead and say alloc info, and let's see what we need to fill in here. We need to set the command pool, and we are basically passing that in through the function call. And then let's do alloc info, and let's see, let's just take the level here, and the level has to do with whether or not this is like a primary buffer or not. So what I'm going to do is I'm going to check the variable that we pass in, whether it's primary or not, right? So if it's primary, right, what we want to do is you want to set this level to VK, and I think it was command buffer level primary, like this. Okay, otherwise it's secondary, right? So we can just say VK command buffer level secondary, like so. Easy, right? And then from there, all you need to then do is do the alloc info. And what else didn't we fill in? Pool buffer count. I think we want to add this one, yeah, like so. And then what's left? The pnext. Well, we don't have any, so we can maybe set this to 0, but because I did this like this here, it's automatically 0, so it's fine. And then the next thing is to just allocate that buffer, right? So let's do VK command buffer, well, not command buffer, but allocate command buffers. And what we want to pass in here is the logical device and the allocation info, so the alloc info. And then what we want to do is the command buffers, the command buffer, VK buffer, so we basically passing in the buffer that we're creating, so like so. Sorry about that, just copy this, paste it in here, and that should be the out buffer. Okay, and we want to check if this is equals to VK success or not. So VK success, and then if it's not, and then essentially we just want to throw an error here. So we're gonna need our info here, our logger. So let's do core/logger.h, and then we're gonna do error and then we're gonna say failed to create, well, not create, but reallocating. So failed to allocate command buffer. All right, and I just noticed that since we have the possibility of failing, this should return a boolean. So let's just fix that. So let's say bool here, and then go back in the header file and just change this from void to boolean and save, and then come back here and we will return false in case it fails. So return false, otherwise return true, meaning that we've successfully allocated our buffer. All right, sweet stuff, nice. So now let's move on to the free. The free should be very, very easy. All you need to do is just call VK free command buffers and I just need to pass in the logical device here, the command pool. So our command pool, we also passing in when we call this function, and then the buffer count is just going to be 1, and then we need to pass in the command buffer. So what I'm going to do here is just say the command buffer, like so. Okay, and that's it. Literally that's it. And also what I want to do is just say cmd buffer equals to 0, okay, because we freed it. So this will free it, but then we will also ensure that we indeed definitely free it and set it to 0. And yeah, and then we can move on to the buffer begin. This will also be another short function. So we only need to do here is just fill out the struct. So let's do vk command buffer begin info, so this one right here, and then we're just gonna call this begin info, and then we're gonna basically set this to 0, and then after that we're just gonna say begin info, and then we're gonna set the s type as usual, and then we're gonna say vk structure type like this, and this should be command buffer begin info, like that. And then we're going to close that off, and then we're going to do begin info, and let's see, flags. Well, let's do flags, it's fine. Our flags for right now it's going to be null. Well, it's going to be 0, we're not really going to have any. And then our begin info, our pnext should also just be 0 really, or I can do what was that keyword again, vk null handle. I can do this as well. I'm sorry, I have flu. But yeah, it's up to y'all how y'all want to do this. But anyway, I just wanted to show you that you can do that as well. Anyway, since we're passing in a variable here to check if it's a single use, we're going to check if it is indeed a single use buffer. And if it is, all we want to do is just say begin info dot flags. Yes, I think it's flags. Yeah, flags. And then we're going to say flags. Since it's a single use, we'll then have to do it like this, right? We need to do it like that. And then we're going to do vk command buffer. I think it was command buffer usage one time. Yeah, I think it's one time submit bit, like so. All right, this will only set the flags to this if it's a single use. If not, then it will default to this one, right? So this will only get overwritten. Well, this will only get overwritten in the case of it being a single use buffer. Okay. And then we can do begin info and then check else what we need. We need the p inheritance info. Well, we don't really need this for now, and I'm just gonna put a comment here and just say not needed for now, at least, right? We might need it in the future, depending on what we really want to do. But yeah, and then we're gonna do, and I realize I'm not consistent with my results here. I should do vk result. This should be result equals to this whole thing. Take this, paste it there, close it, and then this should be the result, like so. Okay. And in case I just want to know what it is, I can just do where is my percentage d, right? Like so, and that's it. Okay. So then here I should do the same, right? So we should basically just say vk result. So vk result equals to vk begin command buffer. And here we need to pass in the command buffer, so we can do cmd buffer, and then we can also pass in the begin info. So add begin info, like so, and it's crying. So what does this want? Dereference with a star. All right, so we need to dereference this because here we're passing it as a pointer. Okay, so once we have that, I think we can just copy this right here. Wait, it does return. So I guess we could also just return false here. So we can return a boolean as well for the begin. So let's do here boolean. So back in here, just quickly save that. So when we begin, we can return false. Otherwise, we return true when it's successful. So like that. Oh man, it's not nice having flu. Anyway, we good now. Next we need to end this buffer, right? We need to end recording. So for this, it's a fairly easy thing as well. So let's just do a vk result here, and this should be vk and command buffer. And let me just double check that it does return a result. Yes, it does. And then this should be our command buffer that we want to end. And it's crying. We have to dereference it again, like that. And then I'm just gonna copy this so I don't have to retype it, like so. All right, so we're gonna end this. Well, I guess most of these functions should just return something. Boolean. Let's do boolean, so it's fine. And then return true here. Oops, true here, like so. All right, that's it. That's literally it. And then for the reset, all we need to do is just say vk reset command buffer, and we just pass in the command buffer that we want to reset, and the flags. For now, I don't really want to pass in any flags, so I'm just gonna default this to 0. However, you guys, if you guys know what you're doing, you can basically pass in the flags here and then pass them in here as well, right? But for me, I'm just gonna pass 0 in there most of the time, so it's fine. Again, I have to dereference this, so it's fine. Does this return anything? Yes, it does. So let me just do this right here. So, and just take this, paste it in here like this, return, and then this should just be a boolean. So buffer reset, let's see, buffer reset, just make sure that this returns boolean like so, and we're good. Right, so now let's see, Vulkan command buffer allocate begin. So how will I do these guys? Well, these guys are actually, it's very simple, because we already have the functionality here to create and allocate a buffer and to begin recording. So I just need to call those in here, right? So that's what I'm gonna do. So I'm just gonna say Vulkan command buffer allocate, and then we're just gonna pass in the logical device, and then we're gonna pass in the command pool. In this case, it's just pool, and then we're gonna pass in whether it is a primary. Now, because it's a single use, for now I'm just gonna default that as a primary buffer, and then command buffer the out buffer. So this is just gonna be the out buffer like so. Okay, so that will allocate the buffer, but because we said also allocate and begin, so we also need to begin recording. So let's do begin here, pass in the command buffer. So let's do the out buffer, and then is single use. That should then be true, okay, because it is a single use buffer. All right, sweet stuff, right? Fairly simple. And then the one for the end is also fairly similar, with just a few extra things going on here, because this one takes in a queue. So to do this, all we need to do essentially is just end the buffer. So let me put a comment here. It's pretty useless, by the way, but I'm just gonna put it. So end the command buffer. So we end it first. So we're just gonna do Vulkan buffer end, and then we're just gonna pass in the CMD buffer. So CMD buffer, and yeah, so after that we end it, and then we basically need to submit to the queue. Okay, so the way that I want to do this is, let's just put a comment here, submit. So let's do vk submit info, this one, and then I'm gonna do submit info, and then I'm gonna set this to 0 like so, and then I'm gonna do submit info dot as type is equals to vk structure type submit info like so. Okay, and then all we want to do is basically say submit info dot command buffer count. It's just gonna be 1, and then we're gonna basically say submit info dot p command buffers, and this one we should just pass in the command buffer. So this is our CMD buffer, and then we just need to submit, okay, the queue. So what was it? I think it was vkq submit, nope, this one, and then it takes in the queue. So I'm gonna pass in the queue, then it takes in the submit count. In this case it's only 1, and then we're just gonna give it that submit info, and then it's gonna take in the fence. In this scenario we're just gonna say no fence, and that's fine. Okay, and then there's a possibility that we can end the buffer while something is still running or something's still not done and whatnot. So what we want to do is basically wait for the queue to finish before doing anything else. So I'm going to basically say wait for it to finish. And then we can just say vkq wait idle and just pass in the queue there, and then it will ensure that this operation finishes first before we can do anything else. Okay, in this case freeing the buffer, so we cannot free it whilst it's still doing some operations, right? So we need to wait until it's completed and then we can do that. So let's just free it. So free the command buffer. So let's just do Vulkan command buffer free, like so. And then this will just take in the logical device and the pool, and then the command buffer. So our command buffer is just the CMD buffer, like so, and that's it. That is literally it for our buffer functions. So yeah, but however, remember now, if you look, where is it, this pool, we're always passing in some type of command pool. We need to create this pool. Okay, this will be our graphics pool, by the way. So what I'm going to do is in the device creation implementation file here, in the function called Vulkan select logical device, right at the end of that function where we're setting up our dynamic rendering function pointers, what I'm going to do here is where I'm going to set up that command pool. Okay, so let's just do setup our graphics command pool. Okay, then I'm going to do vk command pool create info, and then I'm going to be cmd pool create info, like this, and I'm going to set that to 0, and then I'm going to do cmd dot as type is equals to vk structure type, and then this is just going to be the command pool create info. Okay, like so, and then we're gonna have cmd pool create info, and we're gonna do let's do the flags, and then our flags, we're basically creating a command pool here. So all I'm gonna do is I'm gonna set this to vk command vk command, let's see, pool create was it create, or was it create reset command buffer bits? Don't really remember here, but let me see. Reset create reset command buffer bits. I think this is the one we want actually to create, and also have the ability. Yeah, I think I'm just gonna go with this one. If I'm wrong, I'll come back and fix it. Yeah, okay. So then I'm gonna do cmd pool create info, and we're gonna need to give it a family index, right? A Q family index. Now, if you remember back in our device creation process, we say that all our queues are actually at the index 0, because on macOS, all the family indices basically support presentation and everything else that we need. So essentially, it just makes sense to just select the first queue. So in that case, I was located at the 0th index, meaning it's the first in that queue. So I'm just gonna hard code A0 here, and I'm just gonna put a comment for those who still are a little bit confused, because our graphics queue index is at index 0. Well, I really don't know how to write comments. But anyway, there you go. right? But yeah, and then all we need to then do is just check if our pool has been created, right? So I can do if well let's do we have a VK result in here? No, we don't. So I can do VK result equals to VK create command pool, and then it's going to take in the device, so that is in the context / logical device, and then the p create info, so that is the cmd pool create info that we just created right now. And then the allocator, we don't have one for now, so it's just going to be 0. And then the pool is just going to be the one that is essentially stored in the context, and that is the graphics pool, like this. So this is what we're populating with this function. Okay, we are populating this variable, the graphics command pool variable, which is stored in our context, using this function right here. Okay, and we just need to take the reference of that. So just close this function, and also just do a sanity check. So result, if that is not equals to VK success, VK success, and then we can just return false here, and then just throw an error message saying that, hey, failed to create command. Well, let's just be a little bit more specific. Graphics command pool, right? Because we're creating our graphics command pool, like so. So save this, and that's it. That's basically all there is to it, really. So let me just compile everything here and just see if we have any warnings and issues, and we're fine. So let's just rerun the app and see if that still works. We don't have any issues. Let me just see here. Fragment shader created, selected. And yeah, so everything still works. Okay, so let me close this and see if we have any errors, and we have. So it wants, let's see, VK device must have been destroyed. So VK create device, VK command pool, right. So because we created the command pool, we also need to destroy it when we basically delete or close our engine. So let's just do that in here. Sorry about that. Well, that gets created before the graphics pipeline, so we can just basically destroy it here. So VK try command pool, and then we can just say context / logical device, then the command pool that we want to destroy, and that is just our graphics command pool, and then the allocator is nothing. And let's just rebuild this, and then clear all of this, and rerun this, and see we have no errors. So let's close this, and again we have no errors, and that red message is gone. So everything is working as should be. So now that we have the ability to create a command buffer, let's create our command buffers. Okay, so in our Vulkan render.c file, just maybe up here, I guess, I don't know really where to put this, so I'm just gonna put it right here, static. I'm gonna create an internal function called static, that is static. So let's just do void, and then we're gonna call this create command buffers. Okay, like this, and it's not going to take in any parameters, but it will definitely create our command buffers. So all we need to do is just basically do cmd context cmd buffers, and we're just going to basically allocate the array to store our buffers in. So in this scenario, what I want to do is just call our array create function, and then we're going to pass in the type of array, and then the type of the array is going to be of type vk command buffers. Right, it's going to store a list of command buffers, okay, like this. And on second thought, I actually just want to have 2 of these, so let's just reserve space for 2 only. So reserve, so we're just going to say array reserve 2 of these. Now where will I get this number, this 2 number? I could just hard code it as a 2, but normally I want to associate this with the max frames that I have in my swap chain. So let's do swap chain dot max frames, and we don't have max frames. Ooh, interesting. So let's go back to our, where are you, defines.h, and then in here we want to go to the swap chain, and then I'm just gonna put a uin32 here. Well, it's just the u32, and I'm gonna call this max frames in flight. Okay, like this, and I'm gonna save that, and I'm gonna come back in here, and I'm gonna do subchain dot max frames in flight. Okay, and then I did something wrong, I guess. So what is going on here? Oh, I misspelled this, reserve. Okay, there we go. All right, then we're gonna create a for loop to loop through. So I'm gonna set I as equals to 0, and then I'm gonna say if I is less than context slash subchain dot max frames in flight. Then we're gonna basically iterate through that, and that should essentially create all command buffers. So I'm gonna do Vulkan. Remember, we're gonna allocate, so we're gonna do Vulkan command buffer alloc. And then we're basically just going to pass in the logical device, and that is in our context dash logical device, like this. And then the command pool essentially is going to be context slash graphics command pool, like this. And then we are going to set is primary to true, and then we're gonna do, it wants the out command buffer, so that is stored in the context, right? So we created those variables in the beginning of the video, so we can just say context and then cmd buffers and then the one at the current index. Okay, so that should work, right? But now we have a little problem. This number is not set anywhere, but it's fine because we will definitely get to creating it and setting it. But for now, let's just see if it'll work. Create command buffers, so let's just see. Okay, I'm gonna paste that in there, and I'm just gonna rebuild this. I'm expecting it to fail, but let's just see. So it doesn't fail, and when I close this, it doesn't break, but I suspect that this is 0, so it will definitely not create any command buffers. So what I'm gonna do temporarily is I'm gonna take this whole thing, copy it, commented it out, and repaste it in here again, and then I'm gonna hard code a value here too, and I'm gonna do 2, and I'm gonna save this, and I'm gonna rebuild. I just want to see it working, so this is why I'm doing it this way. I'm gonna run this again and see that we have 0 errors, and when I close this, we have 0 errors as well. So in this scenario, the command buffers got created, and everything is working, right? Because we are calling this function in here, so that is sweet. So I can just get rid of that and do this. Right now it won't create anything because this is 0, so just keep that in mind. So I'm gonna end this video here, or I'm gonna pause it here and just see how long it is, and then if it's long enough or short enough, then I might just carry on and set up our Vulkan index, our Vulkan vertex buffers. Okay, these guys right here. But if it's too long, then I might just create that in a separate video. So let's see. Nope. Seems like the video is 44 minutes long. So I won't be able to add the vertex and index buffers because those ones are quite lengthy, require a little bit more setup. So what I've decided to do is I've decided to add just one thing that I actually kind of forgot about, and that is we need our fences, right? Our semaphores and our fences. So for that, what I'm gonna do is I'm gonna just set this up right here in this video so that we don't have to deal with them in another video. Okay, so first and foremost, let's handle this guy here, the max frames in flight. So let's just go back to where we create our swap chain. Let's go to the swap chain.c, and I actually want to populate that in here because this is where we have some of that information that we need. Okay, so right below here, right, so what I want to do is just want to say context slash swap chain dot max frames in flight. This will be simply just image count minus 1. Okay, so this image count is already populated in here. Okay, so we have access to it in here. So this is where I just want to set the value for the max frames in flight. And then also what we want to do is just quickly go back into Vulkan defines.h, and in the context, right, we just want to keep a variable in here. So I don't know, u32, and this will just be the current frame that we add. So let's just do current frame. That's a u32, and then back in here in the Vulkan subchain.c, just right below where we basically set the max frames in flight, I just want to do context and then just say current frame, and that should just be set to 0, right? Right after we create our swap chains. Okay, and then that's it for this section. So I'm just gonna set up, just put a little comment here, just say setup frames in flight. Okay, and then once we're done there, I guess we can go back into the render.c, and then this guy should now point to 2, so it should still work, and it should actually create those buffers for us, those command buffers for us. And if I run this, hopefully everything still works, and if I close it, everything still works. Lovely. All right, so what I want to do is I want to set up our semaphores and our fences. Okay, so what I'm going to do is I'm going to go back into the defines.h, and then right below the current frame, what I'm going to do is I'm going to just add a few variables here. So I'm going to have a vk semaphore, okay, and then vk semaphore, and this one is going to be called, I think it was image available semaphores. And then we're gonna have another one which is just gonna be for the queue. So I'm gonna say queue, and then I'm gonna rename this to complete semaphores, and then we're gonna have one for our fences. So I'm gonna do vk fence, and then this one should be in flight fences like this. Okay, and all of these should be pointers. Okay, so right here I'm just going to do a multi-select and just convert this to pointers. All right, now I'm following the tutorial for these because in the tutorial, in the Vulkan tutorial, well, I actually have the website closed here, but they do have a section whereby they set up the semaphores and the fences. So the technique that I'm using here is pretty much the same one that they're using, and I don't think it's any different, right? So let's just see if the website can just load real quick, then I can show you guys what I mean. But in the Vulkan render.c, right after we create our command buffers, this is where we basically want to set up our semaphores. So what I'm going to do is I'm just going to put a comment here, and I'm just going to say semaphores and fences, and that's that, right? Okay, site is still taking its time. I don't know why the Vulkan website is so slow, but anyway, okay, cool. What I'm gonna do is I'm gonna basically allocate memory for those variables we just created, right? So for the image available semaphores, we're basically just gonna say vk semaphore. Gonna basically cast this, and then we're gonna say malloc, and then we're just gonna say size of, size of, and then the size of that is just gonna be the vk semaphore, and then the number should just be equals to context swap chain dot max frames in flight. This should be 2, right? And then I'm gonna duplicate this a couple of times, and I'm gonna do for the other 2 variables that we created, right? So the other one is going to be q complete semaphores, and then the other one is just going to be in flight fences like this. And then obviously now I have to change this one here to be vk fence of type vk fence, like so. And then vk, everything else should still be the same, right? The number of max frames in flight, and then and then down here we're gonna have a for loop. And then this for loop is just gonna iterate, so it's gonna from I is equals to 0, it's gonna go from I is equals to 0, and as long as I is less than the context dash swap chain dot max frames in flight, then I should increment, and when it's incrementing, we basically create the semaphores. So each semaphore we create needs a struct, a semaphore create info struct. So that's what I'm gonna do. So the website is up, so let me just show you what I mean. Rendering frames in flight, rendering and presentation. I think maybe it's in here. Synchronization, yes. So here it is, right? So we have the vk semaphores. So this tutorial basically shows you guys how to set those up, and I'm literally just following along with how they did it in this tutorial. So you create your semaphores and all that stuff. I'm literally just doing what they did here, okay, in my own way. So let's go ahead and do that. So let's go ahead and do vk semaphore. So vk semaphore create info, and then this one is going to be semaphore info like this, and this should just be 0 in here. Okay, so when I take this, basically do this, and then we should set the s type to vk structure type, and I'm gonna set this to semaphore create info like this. Okay, and then all we need to then do from here is just basically create that semaphore. So vk create semaphore, and we're just gonna pass in the logical device. So let's do logical device and the semaphore create info. So that's the one we just created right now. And then what it needs is the p allocator. We don't have any, and then it wants the semaphore itself. So to store, and then we're just gonna say that is basically in the context at the image available semaphores, and I want you to store it at that index. Okay, just duplicate that line there, and then just rename this one to q complete semaphores, and then logical device semaphore info. Everything else is the same. Okay, so it will create those semaphores for us. And then the other thing that I need to then do is say vk fence fence info, well, vk fence create info, vk fence create info, and then this should just be fence info is equals to this right here. All right, and then all we want to do is basically populate this struct as well, but there isn't really much to populate in here. So let's just say fence info dot s type is just going to be equals to vk structure type fence create info like so. And then I'm going to do fence info dot flags, flags. There we go. I'm going to set this to vk fence and the one that I want is the signal bit. So vk fence create signal bit, and then all I need to do is just say vk create fence like so. And then I'm going to say context logical device, and the p create info, that is just the fence info we just created right now. And then the allocator is 0 again, and then the fence itself is basically stored in the context. So let's do context, and then in flight fences at that current index. Okay, and that's it really. Yeah, that's it really. And then the only thing we need to then do is just create this loop again. So just copy this loop, and make sure that we basically destroy all fences. So I'm gonna paste it in here, and then this loop essentially should just destroy our semaphores. So let's just do vk destroy semaphore. So in this case, we want to pass in the context / logical device, and the semaphore that we want to delete / destroy. So that will be context / image semaphore. And then I'm going to do I like this at that index, and then I'm going to set the allocated to 0 because we don't have any. So I guess I don't know if the order matters. So I'm just gonna do it this way. I really don't know if the order matters, but yeah. And then we're gonna do in-flight fences like so. And then for the in-flight fence, of course this one does not work, so we have to say destroy fence like this. Okay, so that's it. We are done. We are literally done. So let's build again. Let's see if we have any issues, and we have none. Oops, Apple TV. I do not want to open Apple TV right now. So let's clear and let's run the app, and hopefully everything should still work, and it does, because we don't have any errors, meaning this definitely is working. If I close it, everything still works. So the ultimate test here is to remove this line here, right? The destroy function. And what you should do, just make this again, boot the project, run the app, and then close it. And if you get errors, then you know for sure that your code is working. So if I just uncomment these again and reboot, and then rerun the engine, and I close it, you'll notice we don't have any issues. So everything is working, and I think this is where I'll end the video now. I'll see you guys in the next video. Cheers.